Okay, so James Dixon, work with Pentaho. Who's heard of Pentaho? Or Kettle ETL? Excellent, we got marketing people taking note. Okay, so the challenges, there's numerous challenges with big data when it comes to reporting and visualization. We're a business intelligence and reporting company. We've collectively been in this space for decades. So this is an interesting space for us. The first problem, obviously, is the bigness. You've got all of this data, which leads directly to the second problem, which is us. And we have these brains. They're not quite as big as we need them to be. And so the problem is how do we, when we're trying to interpret this data, how do we get all of that data into here? And the answer is that we cannot do it, at least if we want to survive the experience. So the next challenge is linked to the first two, which is the importance. If you look at transactional data, every record of transactional data tells you something important. On this date, someone bought this thing and they paid this much. So there's knowledge that you can gain from every transactional record. When it comes to big data, whether it's a weblog entry, clickstream, machine data, you look at every, one single record doesn't tell you much. You have to step back and look at all this data in aggregate to get something useful out of it. So every piece of big data is like a grain of sand. It's one grain of sand isn't useful. You've got to have lots of it before you can do something with it. So if we look at these first ones, we can take those problems and we can derive the solution there is we need to aggregate this data. The next problem is not just the future, it's predicting the future. The way that we used to do this, because we've been aggregating this data for years, is we determine ahead of time what attributes were most useful. We go to our users, our consumers, find out which attributes are interesting. They will tell us which ones they thought were interesting. We would skim those attributes off. We would aggregate them into data marts, data warehouses. And then the rest of it we put onto tape, which we would never ever go back to. And the problem is that we don't know what we're throwing away in that data. We don't know what attributes are in there that are interesting. So what we really need is ad hoc aggregation. We need to be able to change that aggregation at any point in time when we come up with a new idea about what we want to see from the data. The fifth challenge turns out to be us again. The attention span that we have, particularly if you're doing some kind of interactive analysis of data, the rule from online analytical processing is 5 seconds. This is the optimal time within which, when a user double clicks on something to find out more info, the request goes to the server, you get the data from the database, you do any kind of aggregation or formatting you need to, you get it over the network back to the client, you render it, and 5 to 6 seconds is the target time. So out of this, the database gets maybe 1 second. So what we need is fast ad hoc aggregation. So the next challenge is tools. We're a tool company. We provide tools for doing reporting and visualization. And so what we're doing is we're submitting queries on behalf of the user to get data that they want to see. In order to generate these queries, we need some kind of language with which to express these queries. And because we're doing it programmatically, we need some kind of structure for these queries. So it turns out the only things that we really need from a data source is some kind of structured query language. SQL, no SQL, obviously clearly a problem. But SQL is never the problem. The problem with SQL databases, relational databases, was the transaction support, the latency, referential integrity. The actual query language wasn't the problem. So I prefer to call these databases no baggage databases because SQL is good. It's all the rest of the stuff that's bad. So unfortunately, the tool sets that we have today, we really need SQL in order to be able to get data out and present it to end users. We need some kind of query language that we can manipulate on an ad hoc basis. Again, we're the next problem in that to present information to end users that they can navigate themselves, we need to present them with metadata. I've got an attribute called gender that has San Francisco, 3 possible values, maybe 4. But I've got something called phone number that I'm not going to present you with a list of phone numbers, so phone number may be searchable, whereas gender is something that I can present with a radio button. We need to be able to guide users through this data. So we need things like schemas, we need metadata. So the list of requirements is getting longer. So now we look at, I'm missing a challenge in here. The challenge we're missing is money. We need to be able to do all of this for less than $1 gazillion. Because the value in any one piece of big data is smaller than transactional data. So we've got more of it, and it's actually of less value until we can aggregate it up. We've got budgetary concerns here. So the final challenge here is reality. With the things that we have right now, we don't have the SQL, we don't have the metadata, we don't have the sub-second response time across the entire database. So there's a little bit of work to do here if we want to do that for the budget that we have. Anyone have a paddle? So there's two solutions right here. There are lots of things in the works. So the first one is you can just wait it out. Because there are lots of things coming. There are great things afoot. They're just not here yet. Latency is coming down. Query complexity is going up. But we've got to wait for these things. They will come. In the short term, there's things you can do to be pragmatic. So you can do today, on top of NoSQL data sources, on top of Hive, HBase, MongoDB, Cassandra, we can do web-based and desktop parameterized reporting. You can do batch aggregation and ETL into hybrid architectures. So you can construct these architectures where end users can get to the low level directly, to that low level raw data if they want. But you can also construct these data marts up in the database tier, so whether it's Astrodata, Netezza, Greenplum, Vertica, Teradata, whatever you want in that middle tier, there are things that you can construct today with what's available. You don't have the agility that we will have in the future, but there's two things that we can do during this week. We're going to propose a session for demoing some of the capabilities that we have today using open source tools to do visualization of data from Hadoop and NoSQL. And then we have a training session tomorrow morning, a 3-hour training session from 9 a.m. to 12 that goes through in more detail how to operationalize what you have in Hadoop using graphical environments, and also how to report and do visualization of data that is in HBase, Cassandra, and MongoDB. Thank you.
Great, thank you, James.